Hello everyone, I am Rahul Shandilya, and in this 10th lecture of Internet of Things, we will continue our discussion about sensors and actuators. In the last lecture, we have discussed analog sensors. Now we will continue with the digital sensors. As I have said, analog sensors output in analog signal, that is the continuous signal of continuous electric signal. And most of the natural phenomena, that is, it is a natural signal. You can say it is a natural signal because most of the natural phenomena vary continuously, like temperature and all this things, and they produce electrical signal corresponding. But our computing device is a digital devices, and it can only interpret the digital signals. At some particular step, one have to convert this analog signal into digital form. So there are many sensors that for each analog signal we have to put some say analog to digital converter, and if microcontroller say put large number of sensors, we would have a problem of connecting large, because ADC are limited. Say for example 6 in typical microcontroller of Arduino, we have 6 only 6 pin of for ADC. So we cannot support more than 6 analog to digital converter, or you have to put some extra ADC, external ADC, sorry. So digital sensors are basically are MEMS devices, which by not all the digital sensors, but most of the digital sensors are MEMS devices, which automatically convert into digital forms. They have built some resistors, memories, through which they give access to the sensor's value, the physical parameter value. So we'll look some of the example of digital sensors. Digital sensors do not acquire an external ADC, but report their measurement value directly to the microcontroller in digital form. We know digital form is something that have discrete voltage level. Say in terms of pulses, for example, if I can draw this type of signal, can be said as digital signal. Here the voltage level is discrete, okay, and something like say this kind of signal is analog signal, okay. So button, the most common, the most natural of digital switches sensors is the button and switches, where simply we change the level of a voltage by say pressing a pressing a button, or say switch on some devices. So, is switch change the switch status. The simplest digital sensors is certainly a switch that is either closed or button, where the open or closed state is only activated temporarily. So if you have to say ask what is the difference between button and switch. So button is where open and closed state is only activated temporarily. Means you press it, and as you remove your fingers, it again come back into the previous state. While switch is a device, when you press it, it change their state permanently, not permanently, but retain their state. So in this diagram we can see a connection of switch to a sensor. Here the important thing is a resistor. The switch, the sensors is between this resistor and the switch. The sensor is between this resistor and switch. If instead of switch we have another resistor, we can call this as a voltage divided circuit, as we have encountered in previous lecture. But here there is one resistor which is connecting switch to the higher voltage, and this kind of resistor is called pull up resistor. Pull up resistor, remember this is very important. Pull up resistor that connect your resistor to the external, to the higher voltage, right? So when switch is pressed, and why it is needed, because if you connect this switch, if there is no this resistor, then the high volt is directly connected to the earth, and there will be a large current, or it may be melt your wire, or in fact the large current also harm your sensors. So therefore we have this connection. So when the switch is on, there is develop some potential difference, and as there is no potential, there is no, the switch is in fact say when switch is on, there is no potential difference across this switch. A switch is a device, means it has infinite potential when it is disconnected, and it has zero potential difference when it is connected. So there in the connected state, there is no potential difference across switch S1. Therefore the 5 volt is also appear on this junction, and sensors will get the 5 volt current. And when it is when it is connected, the sensor will get the ground 0 volt, and when it is disconnected, the 5 volt will appear at the sensor. And when it is connected, and the potential difference appears across this resistance of 5 volt, and at the junction it is say at the junction it is 0 volt. So therefore the sensors get 0 and 5 current. Swapping the position of the resistor and the switch resistors as a pull down. The previous was pull up resistor, and if you swap this position of switch and say resistor, now this will be called, then the resistor will be called pull down, because it connect your say sensor to the ground. Then the state, the available of voltage is in reverse order, means when you connect your switch, you will have say higher voltage, and when you disconnect it, you will have the lower voltage. So remember this term pull up and pull down resistor. Basically it is used to avoid direct connection with the higher voltage or the ground. Closing the switch is often accompanied by a fast on-off sequence. Bouncing is avoided. So when you close the sequence, there is a frequent signal is produced, which is avoided by either analog debouncer, which is a simply low pass filter. Why it is a low pass filter? Because this sudden changes, if you look at the in time domain, if there is a sudden change in the voltage, in frequency domain, this correspond to the higher end of the frequency. So we will, if we will use the low pass filter, it will reject the higher end of the frequency, and this uh, transient effect is neglected. Next come after the switch is on off devices. In this category are those devices which gives the value of their sensing parameters as say corresponding to the width of the say pulse. So if the value is higher, the on condition of the pulse, that the higher condition will be more, the width of the pulse will be more, something like that. So it is called the on off devices. There is no fixed say protocol or fixed standard of the in the pulses. Simply it is on off devices, means it use both the state at random to send the signal. For we will look at this in this particular proximity sensors. A proximity device that reports its state through changing voltage level is a PIR proximity sensor. It changes in the infrared radiation level. It changes this. It sends the change in the infrared level, which announce the presence of living being. That is important. It, how it detect a living beings. Every living beings radiates some say infrared signal. This proximity sensors detect this infrared radiation level, and according to the brightness, according to the strength of this radiation level, it detects how much close a living being is there. The sensors are based on collecting the incident infrared radiation with a Fresnel lens on a pyroelectric sensors. The pyroelectric means sensors where the electric signal is produced as compared to say the heat. With according to the phenomena of heat, the electric signal is directly proportional to the heat, and as we know, the infrared radiation is nothing but the heat. Means if a device is heated, although it give radiation in all spectrum, but a living being give radiation in the infrared region, and that's why we felt the heat. So this pyroelectric sensors, this lens is made of polyethylene, a material chosen for its low absorption of IR radiation. So we need a material that absorbs IR radiation, because if it absorbs the IR radiation, that means it cannot detect its correct level. So one side of the sensor is consequently warmed up and expand. Okay, it is a pyroelectric sensor. So based on heat, there is the sensor get warm up and expand, which cause buckling of piezoelectric pyroelectric material, often with polymer film. So as we know that when we a heat is transferred, or when we raise a temperature, a material gets expanded. So it causes a mechanical stress, and then we can see in the figure there is some say this piezoelectric material inside the cavity. So when it feels the stress, it produces the voltage according to according to that stress. So the tiny voltage that is generated is amplified and exposed to surrounding electronics on an output pin that goes from low to high voltage level once it is triggered by the presence of a person, and stays there for considerable amount of time. So basically it gives the only two things: whether any person is present in say a particular range, it gives a signal in the high level of the electric pulse, and if it is absent, then the level is zero. So simply it is an on off devices, means it gives signal, its signal has only two value. On means yes, the person is in proximity, and if it is off, there is no absence of a person or living being. Another on-off device is the distance sensor. So the previous devices, proximity sensors, has two kind of output, say level 1 and level 0. Level 1 presence of person, and level 0 absence of living being. Here we have again, it was a discrete signal, therefore it was a digital signal. Here again we have digital signals, but its output value is continuous, and we have to give it in form of digital. So how it is done? So say let's look at it. A distance sensors. Distance is the analog values, continuous values, and we have to convey it. Several sensors report their measurement value encoded as voltage pulse. So the distance is encoded in this voltage pulse, and with the duration of the pulse proportional voltage pulse with the duration of the pulse proportional to the value, and the duration of the pulse is proportional to the value. This is important thing. So it is also known as pulse width modulation. The width of the pulse is modulated or is changed proportionally to some other signal. So this pulse is also in communication term the carrier, and the modulating signals are the signal. The message signal are modulating signal. One device that employ this mode is SPI4 distance sensors, which operates like a sonar. That means it is based on ultrasonic radiations. It emits a short ultrasonic, uh, say 40 kilohertz sound burst, and record the duration until the echo arrives, which is the round trip time delta day. So this device works same as like the bat, which even the bat also eject the ultrasonic burst and detect its reflection, and according to that it find the path. So the same principle is here. It record the round trip time delta t, and based on this duration time it can sense the distance, and based on this value it varies the pulse duration. The pin on device goes high when the pulse is emitted and returned to low once the echo arrives or some specific time or expires. So next, come to the category of I2C devices. That now we are talking. We'll talk about the signals, or about the sensors that communicate based on some protocol. These protocols are developed especially to communicate between, especially to establish communication between ICs. Say, so we have a protocol like I2C, SPI, and say RS232. We'll look the devices that fall in this category. That means the sensors that support this kind of protocol for communication with microcontroller. A large number of sensors have some logic built in and support high level of communication protocol. An example is I2C protocols operation on the I2C bus. The physical connection to the device support I2C only needs 4 wires. Ground supply voltage needs only the 4 wires. That is, one is the ground, another is the voltage VCC, and remember this all this 4 pin clock SCL stands for clock here. So on chip you will simply see the SCL and SDA, and DA stand for data. So ground is for ground, means the common reference of voltage, and voltage is for the energy, you can say, and SCL is the signal for the clock, and the leg pin for the clock status, and data is the wire through which data is traveled. So how it is communicated, let's see. SCL SDA is used to orchestrate the communication. It configures the sensor, initiate measurement, and then reads data from the sensor. The communication is based on synchronous serial protocol. Remember, this I2C is a synchronous serial protocol. What that means is the data is synchronized with the clock. You hear the data line is sampled every time. That means the data line is sampled every time the clock line changes from higher level to low level. Remember this point. It is a synchronous serial protocol. That means data is synchronized with the clock. That means the data line is sampled every time the clock line changes from high level to a low level. The I2C devices and also I2C sensors have a number of resistors internal that can be written to in order to configure the sensor, or read from in order to retrieve sensor data. Several devices can share the same SDA and SCL lines because each device has its own address and respond only to those messages intended for it by specifying the device address. So same SDA and SCL line can share between different devices. And how microcontroller then say identify that the data is from the particular devices. So each sensors means which support this protocol have, as I said, some internal registers in which some address is stored. Based on this address, we the microcontroller identify the data from what devices the data is coming. So let's see some sensors which support this kind of communication is the barometric pressure sensor BMP085, as well as later is the BMP. So BMP is basically the first term. You will have 085, you have 180, or you have also 280. That are more advanced forms. So they are based on measuring the strain caused by deformation of the membrane that separates evacuated test volume and outside the air membrane with piezoresistive strain gauge. The principle is very simple. So we have there here say the two, here it is some piezoelectric devices. In the silicon substrate, there is a vacuum region, and outside the silicon substrate, say we have the air presses. So there is difference between the pressure and it. The silicon substrate observes some strain, which is say there is piezo, which is recorded by the piezoelectric materials. The piezoelectric materials, due to this strain, produce some electric potential. And again, this device is say based on temperature. So at this region there is also a temperature device. So this temperature sensing material, so these devices can give both pressures, act as a pressure sensor, and also give the temperature value. So the entire assembly is directly built into the silicon substrate, and the strain gauge is created by suitable doping of small sections. This black, the black portion which I have told is the piezoelectric material is created simply by doping. And the strain gauge is created by suitable doping of small section. A temperature sensor is included because the semiconductor based strain gauge is temperature dependent. Semiconductor based strain gauge is temperature dependent, so a temperature sensor is also included. And in most of the cases we need pressure and temperature measurement everywhere simultaneously, so it is an added advantage instead of say the extra redundant measurement. The device communicates with the microcontroller via I2C bus on the address 0x76 or 0x77. The measuring range is from 300 to 1100 HPA, that means hectopascal, with a relative accuracy of 0.12 hectopascal and absolute accuracy. So this is the detail of the measurement. You can easily get it from your notes. So next one that support I2C protocol is the humidity sensor. HY221, HYT931 sensors are that measure the humidity. The operation principle is again very simple. It is made from a material that absorbs the humidity. The operation principles of the measurement is based on the capacitor with a dielectric. Capacitor, remember the capacitor with a dielectric material made of polymer as a sensing medium. So when this material observes this polymer is highly hygroscopic, that means sensitive to the humidity. It absorbs the water, and as it absorbs the water, a dielectric constant change and thus change the capacitance, and the result is the deviation in the voltage, which is recorded by the sensors. Okay, the working is very simple. The change in capacity resistance is determined we using Wheatstone bridge with the capacitor in the two branches. So internally there is a Wheatstone bridge, and the capacitance value changes, and the Wheatstone bridge will also observe that voltage. Another important sensor is the magnetic field sensor, HMC5883. Magnetic field sensors. It is applied in your home. 3-axis magnetic field sensor that is based on the change of magnetoresistive effect. What is resistance due to magnetoresistive effect? So this is simply that a material made by say two ferromagnetic material, say nickel, like nickel iron. The active material is a long meandering strip of nickel iron alloy on a non-conducting substrate. So we have two nickel iron strip, in between there is a non-conducting substrate or dielectric. So when this spin ferromagnetic material or in paramagnetic materials, the electrons spin are aligned. In iron, for example, when it is magnetized, the electron spin are aligned. If the alignment of this the electron spinning is same in both the spread, we have reduced in the resistance, if the alignment of this electron is different in both the nickel iron strip, we have so increase in the resistance. This change is basically measured by the magnetic field. The change of so magnetic field sensors can easily uh, so these materials, if we if exposed to some magnetic field, accordingly it changes the spin direction. The change of resistance is due to change of spin orbit coupling of valence electron in the material. This effect is each with which conduction electron progress the material and consequently the resistance. The active material is part of the Wheatstone bridge whose output voltage is conditioned and amplified before being digitized with an onboard ADC and made available to I2C bus. So here is the detail of this say sensors. It is also used in the compass application for the mobile phones. SPI device. The SPI interface is synchronous and serial communication bus similar to the I2C bus, but it can operate at much higher speed. So this is the difference, that it can operate at much higher speed and is suitable for and therefore often used for devices that require the continuous transfer large amount of data. So that is the difference. If you have to stream the data from some signal, then we use SPI devices. So SPI communication required one master on the bus. It requires one master on the bus and role normally taken by the microcontroller. So in sensor network of SPI devices, the microcontroller role plays the role of master and the sensors are typically the slave devices. They need at least 6 wires to connect. Here we have 6 wires. Remember the ground supply, the supply voltage, the clock, ground, supply, clock. We have these 3 and one line to send information from master to slave, that is MOSI, master out slave in, and one line to MISO, that is master in slave out, and one is the CS line, that is for the clock. Sorry, CS here stands for chip select line to identify the currently active slave. So based if you remember this 6 wire, you can understand how these SPI devices work. CLK MISO MOSI lines can be shared among many slaves, but each slave requires individual chips. We use chip select lines to select different peripheral. If you have say read the microprocessor course, you must be aware of chip select here. Even in digital electronics, here you must have read some devices which have chip select pin. So it is used to select that device. Next and last protocol is the RS-232. Several devices port their measurement value by sending via. It is asynchronous. The most important, it is asynchronous RS-234. There is simply the communication perhaps is point to point between 2 partners, so it has communication between only 2 partners. Remember at a time, not unlikely the I2C and SPI devices. Which is often 9600 baud or 115200 baud is the communication speed. Baud here means the transition rate of the signal, that in a second how many times the signals transition level changes. So 3 wires are required at minimum, one for ground potential, one labeled with transmitter TX. Wherever you see this TX and RX, that means it is for asynchronous transmission, serial transmission. So TX from transmitting from device A to device B, and another level RX for transmitting in reverse direction. So you have to connect TX pin of A to RX pin of B and vice versa. Once the device support RS-232 communication is distance sensors that we have already discussed, also support the RS-232 communication. Actuators. Now comes to the actuators. We have completed sensors. Now comes to the actuator. Actuator is a generic term for a device that controls external parameters. It takes source of data for will read actuator in the next lecture.